Transportation is a sector that uses one of the largest amount of energy. In this module, I talk about the power requirements for different types of transportation systems and discuss the differences between internal combustion engines and other modes of propulsion, which are electric hybrids. U.S. transportation system is the largest in the world, so we will mostly concentrate on the U.S. transportation systems. It is using much of the fuel, petroleum, almost two-thirds of all the petroleum. 27% of the all energy goes into transportation system. As the table to the right indicates, the highway vehicles are consuming about 80% of the total amount of energy. Mainly those are automobile, light trucks, and motorcycle. Buses and motorcycles are relatively, you can see, very small percentage of the total energy which is consumed. I'll get back to that. And then the other 20% is a non-highway vehicles, which include the planes, boats, and railways. I can divide out the modes of transportation into 3 or 4 different subcategories. The surface transportation are the ones that the vehicles that move on the surface and they have wheels. Those are internal combustion engines, electric and hybrid vehicles. Rails are also, a surface vehicle, but they're running on the rail. So I put the different categories. Marines are basically the ships and boats and planes. To run any of these vehicles, I have to use power. And the amount of power is proportional to amount of the resistance we have. The more resistance vehicle faces, the more power you need. The faster you want to go, again, you need more power. So the total power is the product of resistance times speed. If you want to go twice the speed, that means you want to travel the same distance in half the time. Therefore, you need twice the power. So we look at power requirements in the land vehicles. The power has to overcome several types of resistances. First of all, your car has to overcome the resistance at the tires. This is called rolling resistance. The tire has to rotate on the surface. The higher the weight of the vehicle it is, that means there's more push, and the patch area where the tire meets the road will be larger. So there will be larger surface area, therefore there will be larger resistance. It also depends on the road condition and how fast you move, and also the size and the pressure inside your tires. They all determine how much the tires are contacting the road, and therefore the rolling resistance depends on all of them. Then we have aerodynamic resistance. That's a resistance that pushes a car through the air. If the car was traveling in the vacuum, then it would not be any air and there would not be any aerodynamic resistance. The aerodynamic resistance is proportional to the basically density of the air, also the square of the velocity and projected area. If you take a camera and you take the picture in front of the car, what shows on the film is called the projected area. Since the power is proportional to the force times velocity, therefore the aerodynamic resistance becomes proportional to the cube of the velocity. At the very high velocities, this is very important. In addition to rolling and aerodynamic resistance, I need power to climb a mountain. This is to overcome gravitational resistance. Also, the power is needed to accelerate. That is how fast it moves, changes its velocity. So depending on the mass, if the vehicle is more massive, then you need more force, to accelerate it. Also depends on the degree of acceleration. So acceleration force, F equal to ma, is the mass times acceleration. In addition to all of these powers, we need the auxiliary powers, miscellaneous power to run things such as heater, air conditioner, radio, and so on, and horn, etc. Aerodynamic resistance, one of the main factors, which shows by the drag coefficient, depends on the shape of the vehicle. If you look at the square flat plate, you stick your hands off of the car, you experience a lot of drag. As you turn your hand, so we make it, parallel to the wind, then the drag will be considerably lower. A cylinder facing the air has pretty much a lot of resistance. A little bit is slower because of the curvature that the air can travel around the cylinder. A sphere is quite a bit lower because the air can basically turn around the surface, and there will be lower resistance. The best shape which we have in the nature is a teardrop shape. That's the shape of the raindrop. So raindrop are minimizing the amount of drag in order to fall. As you apply, of course, the car doesn't look like any of these shapes. So the truck is boxier, so it has a more drag. The sedan is relatively lower drag, and a car like the Porsche 924 or a newly released car VW XL12 has much lower drag coefficients. So we're looking at a car traveling under the cruising condition or in the city and stop and go traffic conditions. These are very, very different modes. When the car is moving at the cruising condition on a flat surface, then the rolling and aerodynamic resistance are both becoming significant. However, there is no power required, to accelerate because it's at a constant velocity. No power is required to climb a mountain. So those are the major powers that will be reduced. In contrast, during the city driving, you constantly have to accelerate the car between two traffic lights. You have to accelerate it and go on a cruise, and then you stop. And also if there are roads which you have to climb up or down, then you have to accelerate and decelerate during these climbs. So those would be the major drags would be the rolling resistance is always present, the acceleration and gravitational resistances. The cruising resistance is only, the aerodynamic resistance is only significant if you travel at very high speed, usually about the speed of 40 mile per hour, which is rather rare in the city driving. So to summarize, if I want to reduce the power that goes into propelling a car, we have to make the vehicle lighter. To make the vehicle lighter, it is less pressure on the tires, less contact with the road, the rolling resistance will be lower. Lower mass also means lower power to accelerate and lower power to overcome the gravity. So making the vehicle lighter is the first thing that we try to do in designing any vehicle. By making vehicle more aerodynamic, this is particularly important if you're trying to go at the faster speed and the cars are traveling mostly on the freeway speeds. The proper maintenance is very obvious, that you're reducing the frictions on all the moving part, and then we will talk later about the hybrid technologies and using alternative fuels that they can reduce the power. In the aircrafts, I don't go too much into it, but basically the power requirements are similar, except in this case we have to overcome the pressure drags, which is the force acting normal to the surface, and the viscous drag, which is force acting in the parallel to the surfaces. In addition to this, we have a wave drag. The wave drag is when a vehicle, in this case jet aircraft, wants to go to supersonic. As you go from subsonic to supersonic, then a wave is generated in front of the body of the plane fuselage, and that one is basically called the shock wave, and shock wave is associated with major drop in the pressure and causes a lot of drags that we have to overcome.